So here we are, guys. We are going to review some equations and inequalities. If you want to solve an equation, we had 3 steps to distribute when you saw parentheses. So 3x plus 3 times 4, which is 12. And then we looked for combining like terms. So when you see x's that are alike or numbers that are alike, you can combine them. So if I have 3x's plus 1x, that makes 4x plus 12 equals negative 24. And then we undo the operation. So if it says plus 12, we're going to subtract by 12. And then we're going to not multiply by 4, but divide by 4 to get negative 9. Now, there is also a second way that you can solve this by using Desmos. If you type in the original equation and you look at the x-axis, you should be able to see a final answer. So look at the x-axis, which is right here, and it says negative 9. So you could also get your answer of negative 9 by using Desmos. Pretty clever, huh? Especially if you don't remember how to solve by hand. This is at least a Hail Mary that you can type it into Desmos and see what happens. Now, another thing that you can do is there's 2 other types of equations that happen here. So if we do this by hand and we subtract by 2x on both sides, we end up with negative 1 equals 4, which in fact is not true. And we had a phrase that would help us with this. So if negative 1 does not equal 4, that means there are no solutions to this equation at all. And on the reverse of that, if we look at the second equation here, we can combine like terms. 1b minus 6b equals negative 5b. And then we're going to add the 5b's on both sides, and you come out with 1 equals 1. If you get something that is truthful and it does work, then we had a phrase for this as all real solutions. Or you can also say infinite solutions. It means the same thing. Now, if I were to try to cheat and use Desmos on this, you'll note that on both of these, I've zoomed out really far on Desmos, that you will not see anything. And why that is because if you have no solution, there will be nothing drawn. If I have all real solutions, that's literally every single possibility in the world. Hence why you won't see anything. So for those types of questions, please be careful. Sometimes Desmos won't reveal the answer. You actually have to do this work by hand. All right, inequalities, just as a quick recap, guys. If I am an open dot at 7 and I am pointing to the right, then my inequality I could write as, let's say, x, just for giggles. If I'm open and pointing to the right, then my symbol is greater than 7. If I'm a closed dot and I'm pointing to the left at negative 7, I'm pointing to the left and I am closed, I put an underline. In the yellow graph, I'm closed and I am pointing to the right of 7. So pointing to the right and I'm closed means I need that underline. There we go. And the last one here, guys, is an open dot. And from negative 7, we are moving to the left. That's shaded. So we're going to point to the left or less than to create that inequality. Now, if we wanted to solve inequalities, you'll take the same steps as solving an equation. So I'll subtract the 15 and then I'll divide by a negative. When you divide by a negative, guys, be careful, be careful. You must switch your sign in that inequality. That's a big ordeal. Now, if you forget about that and you're not sure how to do it by hand, you can resort to Desmos to type in that inequality. And notice how it gives the answer. It has a bunch of shading. It gives you something on that x-axis to look at. So here I see negative 4. I am also a dotted line, and I am shading to the left, which means that I need this symbol. And I don't put an underline under there because I am a dotted line. So my symbol is strictly going to the left. Dotted line means open in terms of your symbol. And our letter was A. So that kind of clarifies that one. They're using Desmos. If you wanted to solve a compound inequality, since it's sandwiched in between, this guy is what we call an and inequality. So that's why I'm breaking it up by the symbols. So I'm going to do negative 50 less than 7x plus 6. And then in the second inequality across my and is 7x plus 6 is less than or equal to negative 8. And now I can solve that by hand by subtracting by 6 on both sides on both inequalities and dividing by 7 on both inequalities. And you can fuse it all together at the very end. So the lowest I can go is negative 8, but the highest I can go is negative 2. Now, you can also graph this in Desmos, but to do so, guys, you have to type it in separately, just how we broke it apart at the beginning. So you'll notice that your negative 8 is here already. Oops. Blah. So your negative 8 is here. It is dotted. And then we also solidify our answer here with this point at negative 2, 0, which means that our inequality will be sandwiched, or the shaded region between negative 8 to negative 2. So the overlap is where this will happen. Now, another one that you may see is the or inequalities. Now, or faces opposite directions. So if I want to complete this, I just solve each of these mini equations by themselves. So I'll subtract 10, and then instead of dividing by 9 to reverse that, we undo it by multiply. So x is greater than 27, and then I'll do the second inequality by subtracting 16, dividing by 3, and getting x is less than 1. Now, if you don't like doing it by hand, could we use Desmos to help us out? And the answer is heck to the yes. And you'll see that if I type these in separately, ladies and gents, you'll see here that I should have a dotted line there at 1. And I'm shading from 1 down to the left. So that's where x is shading to the left of positive 1. I am a dotted line, so no underline underneath me. On Desmos, I see that from this point of 27, I'm shading to the right, which means that x must be greater than 27. And since this is a dotted line, it should be just greater than, no underline underneath. So that's one way you can look at it. By the way, that kind of looks like the French flag. All right, coming back to the end, if I take a look at an inequality and it's already graphed, sometimes they'll ask you to write the equation of the inequality. And right now this guy is an or, and how I can tell is because they're facing opposite directions. So from here, from negative 6, I am pointing to the left, and I am closed dotted, so I underline it. Here, I am open at negative 5, and I am facing to the right. So you can write that inequality like this. And the last but not least type is our and, where you'll see a sandwich in between, a specific start, negative 8, and a specific end, negative 1. Now, negative 1 is closed, so that means we have an underline. And negative 8 is open, which means that we leave it open. So since you're sandwiched in between, we use the same symbol twice. Or, guys, you could write that x has to be bigger than negative 8, and x has to be smaller than or equal to negative 1, depending on the shading. From negative 8, you're shading to the right. From negative 1, you're shading to the left. So either one of those answers would be acceptable. All right, time to practice.